Hello everybody. Very excited to see all of you. Very excited to be here on this conference. I came from London. Came from London to here. Just wanted to participate in this great conference. And today I want to talk about one of the topics which interests me a lot, about how you can actually leverage LLMs in your day-to-day work. And I work as a ML engineer, and today I want to just talk a little bit about how they help me. Okay, we skipped one slide. Slide was about my career path, so it's probably not very interesting. I have more than 6 years of experience as a ML engineer. I worked in on a lot of different projects. I worked in self-driving cars at Yandex, worked at Booking.com to work with personal data, and now I work in a fun company to build automated customer support. And here is a big idea of today's presentation is that with the introduction of LLMs, we actually see a lot of changes in how pipeline of ML engineering, how it changes, and how AI can be introduced in different parts of this pipeline. In the following slides, I will talk about different parts of the pipeline and how we can use it. Here you can see with the ML engineering pipeline, in many different applications, in many different business cases, it usually consists of the parts which can be kind of like shared between each other, and those are the parts with labeling. So you need to label your data. Second part is about how you judge your models, how you evaluate the results of your work. And the third is about how you actually iterate on your models and how you improve your models in this continuous improvement. Here is the first part of this. What you actually can do to leverage LLMs for data labeling. This is very common problem for many ML applications. If you have experience working with ML projects, ML engineering, for most of the cases, it's a big problem with that you want to start building a model, but you don't have data, and you need to get this data out of somewhere, right? Usually, what people start with, they start with people. They ask them to label the data. But this is usually expensive, slow, inconsistent, and basically people are expensive, people are slow, and you need to do something about it. And this is actually where LLMs come in place, and they can help you with the process, right? And this has some approaches where LLMs can help you. Then can help you clean your data. Then they can help you to just generate labels for the data set you have. And they also can help, this is also a common approach, they also can help you to synthesize your data. And train your model on it. Here's a simple example about how LLMs are often used for labels generation. And this is also known as knowledge distillation process, and it basically consists of when you have a big model and you just want to distill that knowledge into smaller models so you can use it in production with lower latency and bigger scale. And basically what you do is you generate your labels on a data set. And after that, you train your lightweight model. It can be classifier. It can be another NLP model, depending on your task. Here I show a schema from OpenAI blog actually. So this is kind of one of examples they suggest to use GPT-4. What they do is they do exactly this. They do this knowledge distillation. So they suggest to get your data sets, use GPT-4 to generate labels for it, in this case for content moderation based on some predefined policy, and then use those labels to train your model and to fine-tune a small classifier model which can actually work at scale. So here at the bottom right corner you can see you need to run your model at scale with low latency, and that's how you can do it. Yeah, and they also show the results of this process. And yeah, you can see here they compare the results of labels generated by LLM with two sets of humans. First set is so-called untrained humans, so basically humans with no expertise beforehand, just trying to generate those labels, and also humans who are experts in the field. And yeah, you can see that usually humans who are experts, they are always superior to LLM. However, LLM is often doing better than untrained humans, so this approach has its benefits. And of course, LLMs are cheaper, they are faster, they don't require that much effort put into it. Yeah, another interesting thing is that you can also see by category here that for some categories, LLMs are doing much worse than untrained humans. So, for example, for hate, for harassment, and otherwise for some categories, LLMs are doing much better than untrained humans. So, for self-harm category, yeah, this raises a question about why these categories different to each other, and what they are different, how they are different. Yeah, summing up, basically using LLMs is a good leverage about how you can improve your model building process. You can save money, you can save time, and yeah, why not try it in your process? Okay, coming to the second part. LLMs are also can be used to judge your work, to judge work of the model. Yeah, you probably can easily come up with a lot of tasks where you cannot just automatically evaluate the result of the task, right? It usually comes for the task of content generation, some other tasks as well. And yeah, before that, it was really a blocker to building good models. But nowadays, we actually can also use LLMs to evaluate outputs of the model and measure how our responses, are they good or not. Yeah, once again, several different applications of using LLMs as evaluators. So you can use them to compare two models between each other. You can use them to align with humans. You can just try to optimize your model for the human to like it. You probably know that also what OpenAI did with their models, why they became so successful. And another approach is to use them to grade your output. So, for example, for code generation, you can grade is a code style, is it good, is it not good? Yeah, so this is also an interesting approach. And you can always come up with kind of new creative ideas how to use it. I think this is very interesting as well. Yeah, here I propose one example of how you can quickly use LLM as a judge in your production application. It can be any app, right? Yeah, just let's say you have some application running in production. You have your responses. You just need to understand: is your app doing well? Is this chatbot providing good response to your user or not? And you actually can just do it pretty quickly. You just set up LLM judge. You analyze your responses, and yeah, you just write your policy about you want to measure correctness, you want to measure style, you want to measure alignments with human preference, and yeah, you can basically get some measurable results on your traffic, and you can see how it changes with time, and yeah, all of this. Yeah, another interesting case I wanted to share is about this is a paper from 2024 where authors tried to replicate RLHF process, so process of aligning with human preference, but they actually excluded human from the loop. So they replaced human with just LLM judge, and yeah, tried to do basically the same thing. Yeah, you can see the comparisons here. So below you see the process of RLHF. So you use human, you ask him to rate two responses of the model, and you use those ratings to run a reinforcement learning process. And what authors tried to try to do. They just removed human, put the LLM judge into this pipeline, and did exactly the same stuff. And yeah, they actually made it work. It's also pretty interesting. You can see results here. That's, well, actually, you would expect that results of AI RL from AI feedback are a little bit worse than RL from human feedback, as you can see here. But those results are still like much better than performance of just vanilla LLM. So yeah, it makes sense to use this method, and actually like it's much cheaper than asking humans to do it, right? Another interesting point is that reinforcement learning from AI feedback actually did better on some categories once again than reinforcement learning from human feedback. Yeah, summing up, using LLMs to be your judges have several benefits. Once again, you can now estimate things you could not estimate before. You can get this knowledge about your production traffic. You can get this additional knowledge to iterate on your models. And yeah, why not using it in your production applications? Yeah, third part, the part I'm also pretty excited about. I think it is like pretty new thing to try. Is about iterating with your prompts. Actually, so in a lot of cases nowadays, what we just do is we need to write a correct prompt for our task, right? And yeah, what should we do to optimize this? Because usually what you do is you just like you try one thing, you try second thing, you try third thing. You just like prompt engineering is kind of like a maze. You don't know what really works. It's only trial and error. And yeah, here's a picture. It's references to a joke about like if you put a million monkeys, if you give them a million typewriters, they will eventually write like a Hamlet of Shakespeare. But it will probably take like an infinite amount of time. And the same with like ideal prompt for your model. It's very, very long process of trial and error. But yeah, there is a solution. There is a very interesting approach how you can tackle this. So what you basically can do is you can ask LLM to help you. And yeah, probably a lot of you, if you try to write a prompt, you maybe asked LLM to just kind of like write me a prompt, right? So this is the first step, but you can go further. You can actually build a feedback loop, which does exactly this. So you can analyze errors of your LLM. You can like ask to rewrite your prompt based on errors you get from your model. And yeah, you can do kind of like automated search in a space of prompts, which is basically called as automatic prompt optimization, or APO. Yeah. Yeah, here you see kind of like a general idea of APO, how it works. It is all about kind of like building this loop. And in this loop, what you do is you first, like you get your original prompt, and you need a way to kind of like mutate this prompt. And usually use LLMs to do this. You just ask it like change this prompt in some way, do a lot of changes, do kind of like limited amount of changes. After that, you do automatic evaluation of the set of prompts. And for automatic evaluation, you can use, once again, LLM as a judge, as I talked before, or you can use basically different metrics like classification, ranking metrics, just any metric specific for your task. And then, based on those metrics, you select some best prompts, and you start the process once again. Another interesting point in this is that you also can apply some ideas from reinforcement learning here. And what you actually can do is you can balance between exploration and exploitation. Maybe you've heard about it from reinforcement learning. And this is all about that you can either try to explore a big space of prompts. So you can try very different prompts, try them all together to find kind of like in this big space, find the best point. Or you can do exploitation part, which means that you select your prompt which is doing okay, and you just kind of like try to do some fine changes to the prompt, and just like in the near boundary of this point, just kind of like try to find the best existing prompt.
Excuse me.
Yep. Yep.
So is this a manual process or
Well, this process is supposed to be fully automatic. It's kind of like you can do it differently. So you can see here this is evaluation part, and this can be automatic evaluation. This can also be like human evaluation, right? But it works the best if you have automatic evaluation and you have like 100 prompts. You have your like 10,000 rows data set, and you can kind of like evaluate them all together, evaluate them automatically. You can use LLM as a judge. You can use kind of like task-specific metrics for that. So yeah, why not try that?
But have you trained this LLM as a judge by using some
No. No, like why not using just kind of like publicly available APIs to that? Yeah, like no, of course you can go deeper, but here the idea is about like how you can start with this quickly. And so let's say you have one prompt for your task and it's not doing well. So why not trying this? Just like kind of like iterate on this prompt and see where it can get you. Yeah. Yeah, and here another case, it's a paper from 2025 from the people who actually implemented this process. So what they did, they used exactly same algorithm for to do code generation, and you can actually see here is like the same cycle. They start with some original prompts, they do some mutations, they do automatic evaluations. In this case, you can kind of like just evaluate your code, just see if it works, does it solve your task, and then you start once again. And yeah, usually in this kind of like cyclic process, you see that your metrics are converging to some point, and yeah, you can just use early stopping to see like if you're converging, then you just stop and you select the best available prompt. Yeah, and here are the results of this paper. You can see like the most right bar is with using APO, and yeah, you can see that they showed it does show some improvements. It's not that big, but like it's still measurable. It's still, you can see like for this task it worked. And yeah, I once again encourage you to use it kind of like encourage this in different tasks in the business. It's a good approach to try. Yes, and summing this up, this also brings a lot of benefits. This is kind of like allows you to scale the process of prompt engineering, right? So before you had this kind of like trial and error thing where you needed a lot of human effort to optimize your prompt. Now you can scale it. You can do it automatically. You can like kind of like align your prompt with your data, and yeah, this is kind of like pretty cool. And another important point is also about like what gentleman asked. It is also pretty useful that you actually do not need to do fine-tuning, but you can like instead do this prompt optimization technique. And so this also unlocks a lot of possibilities to use closed source models. So only thing you need is an API, and that's it. So yeah, this is also a pretty cool thing. Yes. Yeah. So this brings us to an end. Basically, what I talked about here is about how LLMs can be inserted into different parts of ML engineering pipeline, into a pipeline of how you build your models. And we didn't have this like 3 or 4 years ago. We didn't have this. We have this now, and this kind of like brings a lot of possibilities to ML engineers about like how you can change your work, how you can build better models. And yeah, I encourage you to try this. I encourage you to learn more about it. Yeah, thank you.